Now we'll see the rational, otherwise basis behind this Booth's multiplier coding. Okay, so how Booth recoded the pattern, I will tell you. What was his goal is to reduce the number of operations. That's why whenever he has seen this kind of block of ones, what he realized is, so he realized that he can convert them into another pattern, so that that pattern contains very less number of ones, so that that pattern will consume less number of operations, add operations. We will see how he formed it. So here, first of all, I will tell you one thing. Whatever the binary pattern it is, when you have this kind of block of case in somewhere, let us number them. This is ith position, otherwise I plus 1th position. This is I plus 2's position. So rather than taking variable ith position, I plus 1 position, rather than that, I will tell you this one's weightage is 2 power I. This second one's weightage is 2 power I plus 1. This third number's weightage is 2 power I plus 2, so on. This last one before this 0 is 2 to the power of I plus k minus 1. Okay, let me ask you one question. 2 cube, 2 power 4, 2 power 5, 2 power 6 are the weightages of 4 ones. Okay, then how you relate this number of ones with respect to this 6 comma 3? So 6 minus 3, because these are all consecutive numbers, where 3 to 6, how many numbers are there? 6 minus 3 plus 1, correct? 6 minus 3 is 3, 3 plus 1 4. So if you don't have clarity, then you take more number of such values. Okay, 2 power 3, 2 power 5, 2 power 6, 2 power 7, 2 power 8. Then if these are all the positions of or weightages of some ones, such number of ones, I will tell you. Take 8, take 3, 8 minus 3, 5, add plus 1, 6. There are 6 ones, check it out, correct? So that's obvious. Now here also you have some sequence of ones which are starting with weightage 2 power I2, 2 power I plus k minus 1. Then how many such numbers are there? That means how many ones we have? I will check it out. I plus k minus 1 minus I, we should do subtract, like 8 minus 3, 5 in the previous example. Then we added plus 1. Here also I plus k minus 1 minus I, if you cancel, you get k minus 1, add plus 1. K minus 1 plus 1, k plus k, right? So that means this k indicates number of ones. We can easily find out that number of ones using this last index and first index in this block of ones. Okay, now so what I'm going to do is, whenever you have a number 1 0 1 1 0 something, what is the value of this number? Forget about whether it is negative or positive. First of all, assume that this is a positive number, that's why I added 0. I would like to ask you one question. What is the value of this 1011? Will it depend on this 0 and 0? Let's say you know the positions 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4. What I would like to say is, example, let's say this is 1. Still, so in this entire sequence of patterns, what is the weightage of this 1011? Obviously, always it would be 16 plus 4 plus 2, 22, correct? So the total number of course is 23. What is the reason it is 23? Because this is 22, this is 1, correct? So what I want to tell you is, if this is 22, then overall number, if this is 1, then always the total is 23. If this value overall is something 37, then total will become 38, correct? So that is one important thing you should understand, though it is very easy to understand. Now in this entire binary pattern, I would like to know I would like to know the decimal value of this weightage, right? So every bit is going to give some value, right? So what is the value which is attained by this one, this block? Okay, that is nothing but 2 power I into 1, 2 power I plus 2 power I plus 1 into 1, right? 2 power I plus 1 plus 2 power I plus 2. This is the value obtained by this way, this block of ones, correct? Up to 2 power I plus k minus 1. Now what I want to tell you is, if I simplify it, if I take 2 power I common, then the remaining thing is 2 power 0 plus 2 power 1 plus 2 square, so on, 2 to the power of k minus 1. So here it would become 2 to the power of I into, right? So 2 power 0 to 2 power k minus 1, if you simplify, you get 2 power k minus 1. So according to GP series, okay? So many times we have seen in data structures and algorithms how to simplify it, right? So if you don't know that, then please learn GP series. So 2 power k minus 1 into 2 power I. That if I simplify, you get 2 power I into 2 power k, 2 power I plus k minus 2 power I. So this is final thing. What I want to tell you is this entire value is equivalent to 2 power I plus k minus 2 power I. So what I will do is I remove all these ones and I will keep zeros. Still the value cannot be affected. Sir, why sir? We will see. And here I write minus 1. Okay, here I write plus 1. That is what Booth did. So that's why whenever there is a transition from 1 to 0, that means that is the last one. And whenever there is a transition from 0 to 1, that is the first one. Then that means the remaining things are sequence of ones. Then all that sequence of ones are replaced with zeros. And the last one with plus 1, this one with minus 1, right? So, sorry, there is a small mistake. Actually, we have to take minus 1 here, but this is also 0. Okay, this bit is because what is the weightage of that? You check it out, 2 to the power of I plus k. I want to get 2 power I plus k. That means I should go to a weightage of 2 power I plus k. So this he made 2 plus 1. Okay. So when he does that, what is going to achieve? We'll see. So now we'll see the weightage of this one. 2 power I plus k into 1, 2 to the power of I plus k minus all zeros, right? 2 power I plus k minus 1 into 0, 0, everything is 0. Then finally here there is some significant weightage. What is that? 2 power I into minus 1. So minus 1 into 2 power I is nothing but minus 2 power I. So we got the same value. That means we can easily change all the sequence of ones to this kind of pattern. That is what he did. That's it. So because of that, what happened? You got lot of zeros. When you have 0 in the code, that means what? No add operation. Correct? Initially we had lot of ones, right? All that ones are changed to only 2 ones. So when you have 100 ones, then we are replacing that 100 ones and we are converting them to only 2 ones. Right? Of course, 1 plus 1, 1 minus 1. So 100 operations will become 2 operations. That is what the rationale behind this, otherwise basis behind this Booth's recoding. Okay. Now one more case we should cover actually. We assume that after block of ones like this, so you thought there is a 0, right? What if there is no 0? If there is a 0, then you are right. Correct? But sir, what is the significance of that 0? What if there is no 0 after block of ones? That means this is maybe rightmost bit, right? This one may be rightmost bit. Then only there is a chance that there is no 0. Correct? If this is not rightmost one, then there should be another one. Correct? There should be another one. There should be another one. Then suddenly you may get 0. But if there is no 0 means what? The last one is nothing but rightmost digit of this entire binary sequence. Sir, our question, so far whatever the formula you used, that is like this, right? You thought this is 2 to the power of some I, you said this is 2 power I plus 1, so this is 2 to the power of I plus 2, so on. We understood. This is 2 to the power of, let's say, I plus k minus 1. We understood that. But there is no 0. If there is no 0, it is a negative number, right? It's a 2 in the 2's complement. Its weightage is minus 2 power I plus k minus 1. In the previous example, what is the weightage you took? 2 power I plus k minus 1, correct? But here actually you supposed to take minus 2 power I plus k minus 1. Still it works. Why it works, I will tell you. So whenever you have this one, 2 power I plus k minus 1, when this is last one, then the weightage is minus 2 power I plus k minus 1. Let's have that same. Okay. Now we will see. What I am going to do is same operation. What is the value of this entire sequence of ones I am observing? So if I observe all that values, it would be like this. Minus of 2 power I plus k minus 1 plus now 2 power remaining thing as it is, right? 2 power I plus k minus 2, right? So plus 2 to the power of I plus k minus 3, so on, up to 2 to the power of I. Only simplify up to this part. When you simplify this part, what are you going to get? Did you remember the formula? 2 power I to 2 power I plus k minus 2. If I take 2 power I common, what is going to happen is, so 2 power 0 plus 2 power 1 I am only simplifying up to here. 2 power 1, 2 square up to 2 to the power of k minus, yes, k minus 2. Plus this part, okay, we'll see that later. Now if I simplify it, it would be 2 to the power of I into 2 to the power of 0 plus 2 power k n minus 2 is nothing but this is GP series. Already I taught you so many times in data structures and algorithms, right? So the formula for GP series is nothing but 2 to the power of, so summation I am directly writing. Remember one thing, a plus AR square so on AR power k minus 1 is some series like this equal to a into r power k minus 1 by r minus 1. This is what I am using. Okay, a into, what is the first term here? First term is 2 power 0, right? Let us take the sequence 2 power 0, first term 1 into ratio power k. What is ratio? 2 power, number of terms 0 to k minus 2, k minus 1. Here this is number of terms. So a power 0 to a power k r, sorry, this is not a power 0, a into r power 0. A into r power 0 to a into r power k minus 1, number of terms are k. Here number of terms are k minus 1, minus 1 by r minus 1, 2 minus 1. So it would be 2 power k minus 1 minus 1. So remember that. That means if I simplify it, you get 2 to the power of I plus k minus 1 minus 2 power I. This is as it is, right? Now come to last one. So I am replacing this minus 2 to the power of I plus k minus 1 plus 2 to the power of I plus k minus 1 I got here minus 2 power I. So 2 power I plus 1, I plus k minus 1, this is also 2 power I plus k minus 1, but it is minus, right? They will be cancelled. Now you have minus 2 power I. So whenever you have that kind of situation, then the overall weightage is minus 2 to the power of I, correct? So that means what? Only in the 2 to the power of ith position we have to write minus 1. Okay. So what I would like to tell you is, when you have this kind of situation 1 1 1 1 1 1 1 1 something, so after that 0 followed by some other stuff, I don't want to bother about this remaining part. In the same way I can simplify this part also. So this is, let's say, 2 to the power of something 9, okay, 2 power 10, 2 power 11, 2 to the power of 12, 2 to the power of 13, 2 to the power of 14. So it becomes huge number. That's why, to have easy understanding, let me take 2 cube, 2 power 4, 2 power 5. So let me reduce some ones also. 2 power 6, 2 power 7, 2 power 8. So according to Booth's multiplication, so when you have 2 power 8 to 2 power 3, the summation will become minus 2 power I. So that means minus 2 to the power of 3. That's why, to have that, what Booth did is, in the recoding, so he did, that's why this part here he wrote minus 1. Now easily we can understand, recall. Whenever you have 0 to 1, what we did? We wrote minus 1, that's why. So just remember it. After that, all these ones are removed. You know, of course, the conversion, right? So don't worry about that. So that all these will become zeros. So if really it is done like that, so what is going to be the value? The value is automatically minus 2 to the power of 5, because this is 2 cube position, right? 2 cube into minus 1, minus 2 cube. So here minus 2 to the power of 5. That's why, again, still it is meaningful. That is what finally Booth did. What he is doing is, he observed the consecutive ones and he simplified with, only, in this problem only one expression is getting, only one value is getting 2 power I. So this entire set of ones are equivalent to writing 1 here followed by all zeros. So when he writes more zeros, then the number of additions will be reduced. That is what the idea. Okay, now we'll see one example and we do the same stuff. Okay, so here, so what finally Booth did is, first of all we'll write weightages: 2 power 0, 2 power 1, 2 square, right? Now here 2 cube, 2 power 4, 2 power 5, 2 power 6, 2 power 7. Now this is the case where we have, 2 to the power of I plus k. Formula is, for this one is 2 power I plus k minus 2 power k, right? Sorry, 2 power I. So this is what the simplification, 2 power I plus k minus 2 power I here. So the k is here 3, correct? So blindly remove these 3 ones and write this value, 2 power I plus k. What is I? I is nothing but, here this is 2 power I, correct? 2 power I, 2 power I plus 1. Recall, in our computation it is 2 to the power of I plus k minus 1. So this is 2 power I value 0. So it would be 2 to the power of I plus k, 2 to the power of 0 plus 3 minus 2 to the power of I is 0. So 2 cube minus 2 power 0. So what he did is he felt that this triple one is actually weightage 7, you know that, right? So he wrote, that's why 2 cube minus 2 power 0, that means 2 cube minus 1. So that is what the idea, very easy idea, of course. Okay, so to have achieve 7 rather than 3 ones, what he did is he did 2 cube minus 2 to the power of 0. So 2 to the power of 0 should be minus 2 to the power of 0. That's why he wrote minus 1. That's why initially whenever he sees 1, he imagined a dummy 0 here with respect to that. So he felt like there is a transition. That's why whenever there is a transition, that means that indicates this is the first one. So whenever he sees the first one in the block, that should become what? Minus, right? So here see minus, that's why we wrote minus 1. Now after that 2 cube. So how to imitate 2 cube, how to get weightage of 2 cube? Here we have to have 1. Now everyone just recall our Booth's recoding. 0 to 1 minus 1, that's why intentionally we wrote minus 1. Next 1 to 1, right? There is no transition, 0. 1 to 1, there is no transition. Now 1 to 0, there is a transition, we said, that means the transition indicates that this is the end of the block. Whenever you have end of the block, that next position should have a weightage of 1. That is what we realized, because it is 2 cube, this is 2 to the power of 0 weightage. So in our calculations, recall, 7 is nothing but, if you simplify, you get 2 to the power of 3 minus 2 to the power of 0. This entire story is related to writing here minus 1 to minus, see, 0 in the 0th position, in the 3rd position, but we have up to second position once. That means we have to write in the 3rd position. 3rd position is indicated by 0 after 1. So that's why whenever you see 1 to 0 transition, so we directly went and we wrote plus 1. So that's why whenever you see 0 to 1 transition, that indicates that that is the start of the one, that means first one. So in the first one always we have to write minus 1. That is the idea. Okay, similarly same story happens here, right? Now recall, the simplification of this entire thing is minus 2 to the power of I, where I is nothing but 5. So finally we have to write minus 2 to the power of 5, sorry, not minus 2 to the power of 5, just 2 to the power of 5, correct? So we should write minus 2 to the power of 5, minus 2 to the power of 5, blindly write minus 2 to the power of 5. That means, so here we have to write actually minus 1. In our Booth's multiplication also, see, that's why whenever you see 0 to 1, we will be writing minus 1, correct? That's why after that, whenever there is a transition 1 to 1, 1 to 1, we did not write anything, because that entire thing is simplified to only one term called minus 2 to the power of I. That's why here we write minus 1 in the conversion. Now remaining things, 1 to 1, don't write anything, 1 to 1, don't write. That means simply write zeros, right? So that is the story. So if you don't understand, also not a problem. So, and if you have time, then only you read this video, otherwise it is not required. Okay, so in GATE exam they ask very easy questions, but sometimes out of the curiousness, if you want to know better things, always it would be good, right? So that's why when you have time, do all this stuff. If you don't have time, then skip, because when there is no time, if you unnecessarily waste your time in this kind of mathematical stuff, then you can't focus on important things, right? Maybe you may miss very easy things. That's why don't do that. When you have enough time, then only you try to understand. Okay.